Right now, in a laboratory deep beneath the Swiss Alps, scientists are smashing particles together at 99.9999991% of light speed. These protons are moving so fast that from their perspective, the 27-kilometer ring they circle in has compressed to just 10 centimeters. Time itself has slowed to a crawl for these particles. What takes a fraction of a second in our world stretches to what feels like minutes in theirs. Yet despite all this speed, despite all this energy, despite decades of trying and billions of dollars spent, we cannot push them that final 0.00009% faster. That last tiny fraction of a percent requires more energy than exists in the entire observable universe. This is not an engineering problem. This is not a limitation of our technology. This is the universe itself saying no. Tonight, we explore why the speed of light is not just a speed limit, but an absolute barrier woven into the fabric of reality itself. And what we discover will change how you think about space, time, and what it means to move through the cosmos. Welcome to Cosmic Sleep Stories. If you enjoy these journeys into the mysteries of physics and the universe, I invite you to like, subscribe, and share your thoughts below. Your support helps these explorations reach others who wonder about the same questions. For now, let your body settle wherever you are. There is nothing you need to solve tonight. Simply listen, and let these truths about the universe carry you gently toward rest. Take a slow breath, and let's begin our journey to the edge of possible speed. For most of human history, we believed there were no limits to how fast something could move. If you had a powerful enough engine, if you could generate enough thrust, if you simply kept accelerating long enough, you could reach any speed you wanted. There was no cosmic speed limit, no barrier, no wall you could not break through with enough effort. Isaac Newton's laws of motion, written in the late 1600s, seemed to confirm this intuition. Force equals mass times acceleration. Apply a force to an object, and it accelerates. Apply more force, and it accelerates more. Keep applying force, and the object keeps accelerating forever. There was nothing in Newton's equations that suggested any maximum velocity. For over 200 years, this understanding seemed complete. Trains moved faster than horses. Automobiles moved faster than trains. Airplanes moved faster than automobiles. Each breakthrough shattered what had seemed like natural limits. The sound barrier, once thought to be impassable, fell to test pilots in 1947. Why should there be any fundamental limit at all? Then, in 1905, a 26-year-old patent clerk in Bern, Switzerland, published a paper that would shatter 3 centuries of certainty. His name was Albert Einstein, and he had discovered something that would change everything we thought we knew about motion, time, and the structure of reality itself. Einstein began with a simple observation. Light always travels at the same speed. Whether you are standing still or racing through space at enormous velocity, light always moves at exactly 186,282 miles per second relative to you. This constancy, this fixed speed of light, seemed innocuous at first, just an interesting property of electromagnetic radiation. But when Einstein worked through the mathematical implications, he discovered something shocking. If the speed of light must remain constant for all observers, then something else must change. Time itself must flow at different rates depending on how fast you are moving. Space itself must compress and stretch. Mass itself must increase with velocity. And most crucially, no object with mass can ever reach the speed of light. Not because we lack sufficient technology, not because the engineering is too difficult, but because the universe itself forbids it through the fundamental structure of space-time. As you rest now, let that sink in gently. The universe has rules written into its very fabric. And one of those rules is that light speed is not just difficult to reach. It is impossible. To understand why, we need to explore what happens as you try to accelerate toward light speed. And the story becomes stranger with every step. Imagine you are aboard a spacecraft, floating in deep space, far from any planet or star. Your engines fire, and you begin to accelerate. At first, everything feels normal. You press back into your seat as the ship picks up speed. 100 miles per hour, 1,000 miles per hour, 10,000 miles per hour. The acceleration continues. Soon you are moving at 1% of light speed, approximately 1,860 miles per second. This is faster than any spacecraft humanity has ever built. At this velocity, you could circle Earth in 13 seconds. Yet you are barely moving compared to what is possible. Your engines continue firing. 10% of light speed, 50% of light speed, 90% of light speed. And here's where things start to become strange. You notice that the stars ahead of you have shifted in color. The familiar yellow and white stars have turned blue, then violet. Then they have disappeared into ultraviolet frequencies your eyes cannot detect. Behind you, the stars have reddened, shifting toward infrared and vanishing from sight. This is the Doppler effect, but on an extreme scale. Light from stars ahead of you is compressed into shorter wavelengths as you rush toward them. Light from stars behind you is stretched to longer wavelengths as you race away. But something else is happening too. Something you cannot see, but that instruments on Earth can measure. Time aboard your spacecraft has slowed down. Not by much yet. At 90% of light speed, for every 10 seconds that pass on Earth, only about 4.4 seconds pass for you. You have aged less. Your clocks tick more slowly. Your heart beats at a leisurely pace, while Earth's clocks race ahead. This is time dilation, and it is not an illusion. It is a measured, verified, absolute feature of the universe. Atomic clocks flown on airplanes show this effect. Particles and accelerators show this effect. GPS satellites must account for this effect, or their positioning data would drift by miles every day. Let yourself drift with this strangeness as you rest. Time is not the fixed, universal flow we experience in everyday life. It bends. It stretches. It changes depending on how fast you move. Your spacecraft continues accelerating. 95% of light speed. 99% of light speed. The time dilation grows more extreme. At 99% of light speed, for every year that passes on Earth, only about 52 days pass for you. You have aged 2 months while Earth has aged a full year. The stars ahead of you have compressed into a tight cone directly in front of your ship. The stars behind and to the sides have vanished entirely, as if the universe has collapsed into a single point of light ahead and darkness everywhere else. This is relativistic aberration, a distortion of space itself that occurs at these extreme velocities. But here is where the real problem begins. Your engines are still firing, still providing thrust, still pushing you forward. Yet your velocity is barely increasing. At 99% of light speed, the same engine thrust that once accelerated you rapidly now barely nudges your velocity upward. You push to 99.9% of light speed, then 99.99%, then 99.999%. Each additional 9 requires exponentially more energy than the last, and your velocity gains become smaller and smaller with each increment. This is not a failure of your engines. This is the universe pushing back. To understand why, we need to talk about mass, or more precisely, about relativistic mass. As you accelerate toward light speed, something strange happens. Your spacecraft begins behaving as though it has more mass than it started with. Not because atoms have been added to it, not because anything physical has changed, but because energy and mass are equivalent, and the energy of your motion has become so enormous that it manifests as additional mass. Einstein's famous equation, E=mc², tells us that mass and energy are two sides of the same coin. As you pump energy into your spacecraft to accelerate it, that energy does not just produce velocity. It also increases the effective mass of the ship. At low speeds, this effect is negligible. A car traveling at highway speed gains perhaps a few extra atoms worth of mass. You would need the most precise instruments in the world to detect it. But at 90% of light speed, your spacecraft behaves as though it has more than twice its original mass. At 99% of light speed, the effective mass has increased by a factor of about 7. At 99.9%, the factor exceeds 22. Let that number settle as you drift deeper into rest. Your ship has not physically gained mass. No atoms have been added, yet it responds to force as though it weighs 22 times more than it did at rest. This mass increase is not some quirk of calculation. It has real, measurable consequences. Particle accelerators encounter this effect every day. When physicists accelerate electrons to 99.9999% of light speed, those electrons behave as though they are tens of thousands of times more massive than they were at rest. The Large Hadron Collider, that 27-kilometer ring beneath Switzerland where protons race at 99.9999991% of light speed, must account for this mass increase in every calculation. At that velocity, each proton behaves as though it has about 7,000 times its rest mass. The protons have not gained 7,000 times more matter. They have simply moved so fast that their kinetic energy manifests as mass. And here is the cruel mathematics that makes light speed impossible. As velocity approaches light speed, effective mass approaches infinity. To accelerate an infinite mass would require infinite energy. But infinite energy does not exist. Therefore, nothing with mass can ever reach light speed. This is not a matter of building better engines. It is not about finding more powerful fuel. You could have all the energy in the universe, every joule of every star, every quantum of every photon, and it would not be enough. The final infinitesimal approach to light speed requires more than all the energy that exists. The universe has built a wall, and the wall is made of mathematics itself. As your eyes grow heavier, imagine this barrier. Not a physical wall you could touch, but a mathematical asymptote. A curve that rises toward a limit it can never quite reach. You can get closer and closer, adding 9 after 9 after 9 to your percentage of light speed. But you will never arrive. Now let's explore what this means for the dream of interstellar travel, and what loophole the universe provides for those who understand its rules. The nearest star to our Sun is Proxima Centauri, approximately 4.24 light-years away. This means that light, traveling at its maximum speed, takes 4.24 years to cross the distance. For anything moving slower than light, the journey takes longer. The fastest spacecraft humanity has ever built, the Parker Solar Probe, reaches speeds of about 430,000 miles per hour during its closest approaches to the Sun. This sounds impressively fast. It could cross the United States in less than 30 seconds. Yet at this velocity, the journey to Proxima Centauri would require approximately 6,600 years. A human lifetime, even a long one, spans perhaps 80 or 90 years. At our current maximum speed, you could cover barely more than 1% of the distance to the nearest star before your heart beat its final rhythm. This is the crushing reality that early space pioneers faced. The star seemed forever beyond reach. Not just difficult to reach, not just requiring better technology, but fundamentally inaccessible within any meaningful human time frame. Many 20th century physicists concluded that interstellar travel was essentially impossible for biological beings. The distances were too vast. The velocities required were too extreme. The energy demands were too enormous. And the light speed barrier made reaching the velocities necessary for reasonable journey times physically impossible. The cosmos seemed designed specifically to prevent life from spreading between stars. Each stellar system appeared to be an island, separated from its neighbors by gulfs that no ship could cross, no matter how advanced the civilization that built it. Yet hidden within the equations that seem to imprison us lies a loophole so profound that it transforms everything. This loophole was discovered by the same man who revealed the light speed barrier, and it offers a way to reach the stars that does not require exceeding light speed at all. Let yourself rest with this mystery for a moment. The barrier is real. The prison seems absolute. Yet the prison has a door, and the key has been known for over a century. The loophole is called time dilation. And to understand it, we need to revisit what happens to time itself as you approach light speed. We have already seen that time slows down for fast-moving objects. At 90% of light speed, time passes more slowly for the traveler than for those who remain at rest. But we have not yet explored just how extreme this effect becomes as you push closer and closer to light speed. At 99% of light speed, a journey to Proxima Centauri would take approximately 4.3 years from Earth's perspective. Light takes 4.24 years, and you are moving only slightly slower than light. But from the traveler's perspective, the journey would take only about 7 months. Time dilation compresses the experience duration by a factor of about 6. You would board your spacecraft, accelerate to 99% of light speed, coast for most of the journey, decelerate as you approach Proxima Centauri, and arrive having aged only 7 months. Meanwhile, Earth would have aged 4.3 years. Push the velocity to 99.9% of light speed, and the numbers become more dramatic. The journey still takes about 4.24 years from Earth's perspective. But from the traveler's perspective, the trip lasts only about 2 months. You would arrive at the nearest star having aged less than most people age during a summer vacation. At 99.99% of light speed, the traveler's experience compresses to about 6 days. A week-long journey across 4.24 light-years of space. At 99.999% of light speed, the subjective journey time drops to about 20 hours. Less than a day of travel to reach another star system. As you drift towards sleep, let these numbers settle. The universe is not preventing interstellar travel. It is simply requiring that travelers understand the relationship between velocity and time. Move fast enough, and distances that light requires years to cross can be traversed in subjective moments. The mathematics continues relentlessly. At 99.9999% of light speed, you could reach Proxima Centauri in about 6 hours of subjective time. At 99.99999%, the journey compresses to about 2 hours. The star system that is 4.24 light-years away becomes accessible in less time than a movie. From Earth's perspective, these journeys still take years. Light speed is light speed, and you cannot arrive before a photon that left when you did. But from the traveler's perspective, time dilation compresses the journey into durations that feel brief, almost ordinary. This effect scales to more distant destinations. The Pleiades star cluster, that famous grouping of hot blue stars visible in winter skies, lies approximately 440 light-years from Earth. At conventional speeds, reaching the Pleiades would require hundreds of thousands of years. But at 99.9999% of light speed, with appropriate time dilation, the subjective journey drops to about 6 years. You could travel to one of the most famous star clusters in human mythology, explore multiple stellar systems, and experience the journey as lasting less than a decade. Meanwhile, Earth would age for 140 years. The center of our galaxy, with its supermassive black hole containing 4 million times the mass of our Sun, lies approximately 26,000 light-years away. At 99.999999% of light speed, the subjective journey time falls to approximately 37 years. A traveler could leave Earth at age 25, journey to the gravitational heart of our galaxy, and arrive having aged to 62. They would return to find that over 52,000 years had passed on Earth. Human civilization would be unrecognizable or extinct, but they themselves would have lived a normal human lifespan. Even more remarkably, the Andromeda Galaxy, at 2.5 million light-years distance, becomes theoretically accessible. At velocities where time dilation factors reach into the millions, achievable only at speeds so close to light that the difference becomes almost philosophical, the subjective journey time to Andromeda drops to approximately 2.5 years. A traveler could cross the void between galaxies, explore an entirely separate island universe, and experience the journey as lasting less time than a typical graduate program. Earth would age 2.5 million years, but the traveler would age only a few years. Let that wonder wash over you as you rest. The universe has not built walls to prevent cosmic exploration. It has provided a mechanism, time dilation, that could carry human consciousness across distances that light itself requires millions of years to traverse. The limiting factor is not physics. It is engineering. We lack the technology to achieve the necessary velocities, but the equations permit it. The mathematics allows it. The universe, in its strange mercy, has left the door open. Now, as we drift deeper, let's explore why this loophole does not violate the light speed barrier, and what it reveals about the nature of space and time. Time dilation seems like a cheat. If you can reach Proxima Centauri in hours of subjective time, have you not effectively traveled faster than light? Have you not crossed 4.24 light-years of space in less than the 4.24 years light would require? The answer is subtle, and it reveals something profound about how the universe actually works. From your perspective aboard the spacecraft, moving at 99.999999% of light speed, you have not traveled 4.24 light-years at all. This is where length contraction enters the picture. Space itself compresses in the direction of motion. At these extreme velocities, the distance to Proxima Centauri, as measured from the spacecraft, has shortened dramatically. At 99% of light speed, the 4.24 light-year distance compresses to about 0.6 light-years. At 99.9%, It compresses to about 0.19 light-years. At 99.999%, the distance drops to approximately 0.006 light-years, or about 35 billion miles. At 99.999999% of light speed, where the journey feels like it takes about 6 hours, the distance from the spacecraft's perspective has compressed to approximately 130 million miles. About the distance from Earth to the Sun, you have not traveled 4.24 light-years in 6 hours. You have traveled 130 million miles in 6 hours. From your reference frame aboard the ship, you never exceeded light speed. Space itself shortened to allow the journey to complete in the time you experienced. This is not an illusion or a trick of perception. Length contraction is as real as time dilation. Space literally compresses in the direction of motion for fast-moving observers. The universe has not violated its own speed limit. It has bent space and time to accommodate motion at these extreme velocities while preserving the constancy of light speed. Let this settle as you drift. Space is not the fixed stage Newton imagined. Time is not the universal clock we experience in everyday life. Both bend and flex and reshape themselves depending on how fast you move. And both conspire to preserve one absolute rule: nothing can exceed light speed. From Earth's perspective, the distance to Proxima Centauri remains 4.24 light-years. Your journey at 99.999999% of light speed takes 4.24 years. You arrive moments after a photon that left when you did. Light speed has not been exceeded. From your perspective aboard the spacecraft, the distance has compressed to 130 million miles. Your journey at 99.999999% of light speed takes 6 hours to cross that compressed distance. Light speed, measured in your reference frame, remains exactly what it always was: 186,282 miles per second. Both perspectives are equally valid. Both see light moving at the same speed. Both observe the fundamental speed limit preserved. The universe has bent itself into a pretzel to maintain the constancy of light speed, while allowing different observers to measure different times and distances. This is the genius of Einstein's relativity. It is not called the theory of everything being relative. It is called the theory of relativity because it describes how measurements of space and time are relative to the observer, while the speed of light remains absolute and invariant for everyone. The light speed barrier is not a suggestion. It is not a challenge to be overcome with cleverer engineering. It is woven into the mathematical structure of space-time itself. And every experiment, every observation, every measurement we have ever made confirms it. As your breathing slows and deepens, rest in this certainty. The universe has rules, and those rules are not arbitrary limitations imposed by a capricious nature. They are expressions of deep mathematical truths about how reality is constructed. Now let's explore what this means for the energy required to approach light speed, and why even the sun itself does not contain enough power. We have seen that as velocity approaches light speed, effective mass increases toward infinity. This has a direct consequence for the energy required to continue accelerating. Consider a small spacecraft, massing perhaps 1,000 kilograms at rest, about the weight of a compact car. To accelerate this spacecraft to 50% of light speed would require approximately 3.2 times 10 to the 19th joules of energy. Written out, that number contains 20 digits. This equals roughly the total energy output of the sun for 2 seconds, or the entire energy consumption of human civilization for approximately 200,000 years, just to reach half light speed. To accelerate the same spacecraft to 90% of light speed would require approximately 1.2 times 10 to the 20th joules, about 8 seconds of the sun's total output. To reach 99% of light speed, the energy requirement climbs to approximately 5 times 10 to the 20th joules, about 40 seconds of solar output. At 99.9% of light speed, you need approximately 1.6 times 10 to the 21st joules. Over 2 minutes of the sun's complete energy output, concentrated into accelerating a single 1,000-kilogram spacecraft. Let these numbers settle as you rest. We are not talking about advanced engineering challenges. We are talking about energy requirements that exceed everything human civilization has ever produced by factors of millions or billions. At 99.99% of light speed, The energy requirement reaches approximately 5 times 10 to the 21st joules, about 6.5 minutes of solar output. At 99.999%, the requirement climbs to 1.6 times 10 to the 22nd joules, about 20 minutes of the sun's total power. Each additional 9 roughly triples the energy requirement. To reach 99.9999% of light speed would require over an hour of the sun's complete output. To reach 99.99999%, you would need several hours. To reach 99.999999%, you would need the sun to burn for most of a day, directing every photon, every erg of energy, into accelerating your single small spacecraft. And we have not even mentioned deceleration. Everything accelerated must eventually slow down if you want to stop at your destination. Decelerating from 99.999999% of light speed requires exactly as much energy as accelerating to that velocity in the first place. A round-trip journey would double the energy requirement again. Visiting Proxima Centauri and returning would require 2 days of the sun's total output. For one small spacecraft. For one journey. These are not engineering problems awaiting clever solutions. These are fundamental requirements imposed by the structure of space-time. The energy exists in the equations. Either you provide it, or the journey does not happen. There is no shortcut. As your eyes grow heavier, imagine what this means. The universe is not playing favorites. It applies the same rules to every civilization, every species, every attempt to move fast through the cosmos. The barrier is not there to stop us specifically. It is simply a feature of how reality works. The energy requirements explain why we see no evidence of interstellar civilizations racing around the galaxy at relativistic speeds. If such civilizations existed, they would need to harness stellar-scale energies for routine travel. The signatures of such energy use would be visible across interstellar distances. We see nothing. Perhaps life is rare. Perhaps civilizations destroy themselves before achieving such capabilities. Or perhaps the energy barrier is simply too high. Perhaps the universe has designed a cosmos where each star system remains fundamentally isolated, where life evolves and flourishes in lonely archipelagos separated by gulfs too vast and too expensive to cross. Now, as we approach rest, let's explore one final mystery. If nothing can exceed light speed, how does light itself travel at light speed? Photons, the particles of light, have no mass. Or more precisely, they have no rest mass. This simple fact changes everything. For a photon, there is no barrier to overcome because there is no mass to accelerate. From the moment of creation, a photon moves at light speed. It never accelerates. It never slows down. In vacuum, it moves at 186,282 miles per second from the instant it exists until the moment it is absorbed by something else. Light speed is not a velocity photons achieve. It is the only velocity they can have. This creates a strange perspective for the photon itself. From a photon's reference frame, if such a thing can be said to exist, time does not pass at all. The journey from a star to your eye, a journey that might require years or millions of years as measured by external observers, feels instantaneous to the photon. A photon leaving the Andromeda galaxy, traveling 2.5 million years to reach Earth, experiences no time. From its perspective, creation and absorption are the same moment. It is born and dies in the same instant, even though external observers measure millions of years passing between these events. This is the ultimate expression of time dilation. At exactly light speed, time dilation becomes infinite. All durations compress to zero. All distances contract to zero. The universe, from a photon's perspective, is a single point, and all of history is a single moment. Let that strangeness wash over you as you drift toward sleep. Light does not travel through space and time the way you do. Light exists outside the normal flow of time. It connects all points in the universe instantaneously, from its own perspective, even as external observers measure its journey taking years or eons. This is why nothing with mass can reach light speed. To do so would be to step outside of time entirely. To become something other than what you are. To transform from a being that exists in time to a being for whom time is meaningless. The universe does not allow this transformation. The equations forbid it. The light speed barrier is not an obstacle to overcome, but a boundary between two fundamentally different modes of existence. On one side, beings who experience time, who age and change and move through the universe. On the other side, photons, timeless messengers connecting all of space in a single eternal instant. You are on the side where time passes, where change happens, where memories form and futures unfold. The barrier keeps you here, and perhaps that is not a limitation, but simply the nature of being alive. Now, as we gather these threads and prepare for rest, let's understand what all of this means for the dream of touching the stars. We have traveled far tonight through the mathematics of relativity, the physics of space-time, and the absolute barrier of light speed. We have seen that the universe does not prevent interstellar travel. It simply demands that we understand its rules. Time dilation offers a genuine path to the stars. Accelerate to high enough velocity, and distances light requires years to cross can be traversed in subjective moments. The physics permits journeys to other stars, other galaxies, the farthest reaches of observable space, all within a human lifetime measured in the traveler's own time. But these journeys exact a price. The price is connection. Travel to Proxima Centauri at extreme relativistic speed, and you might age only hours while Earth ages years. Travel to Andromeda, and you age a few years while Earth ages millions. You can reach these places, but you cannot return to the one you left. Every journey becomes a journey forward through time, from which no return is possible. The light speed barrier does not imprison us in our solar system. It isolates us in our era. The universe offers exploration at the cost of belonging. You can touch the stars, but you abandon your time. You can cross galaxies, but you become a visitor from the ancient past arriving in an unrecognizable future. Perhaps some travelers will accept this trade. Perhaps the wonder of seeing Andromeda from within, of visiting the galactic core, of exploring star clusters and nebulae far from Earth, is worth any personal sacrifice. Or perhaps the human spirit requires connection more than exploration. Perhaps the best journeys are those that allow return, that maintain threads linking travelers to home, that preserve the possibility of sharing discovery with those who stayed behind. These questions have no universal answers. The universe does not care which choice we make. It offers the same physics to everyone. What we do with those parameters remains entirely our decision. As you rest now, let all the mathematics and equations dissolve. Keep only the essential truths. The universe has rules. Light speed is absolute. Time bends to preserve it. Space compresses to accommodate it. And within these strange flexings of reality lies a door to the cosmos. The door is open. The physics permits passage. The equations allow journeys across cosmic distances within human lifetimes. What we lack is not permission from the universe, but the technology to walk through the door it has left ajar. Perhaps future generations will develop the engines necessary. Perhaps they will build ships that ride beams of light or harness energies we cannot yet imagine. Perhaps they will stand at the threshold of interstellar space and choose to step through, accepting exile from their era in exchange for the gift of cosmic exploration. Or perhaps they will decide that connection matters more than distance. That home is not a place you can leave and return to, but a moment in time that you can only abandon or preserve. That the real journey is not across space, but through the lives we build with those around us. The universe does not judge these choices. It simply maintains its rules. Light speed is absolute. Time dilation is real. The barrier is impassable. And yet, within these constraints, almost anything becomes possible for those patient enough to accept the universe's terms. You exist in a cosmos that stretches billions of light years in every direction, containing wonders beyond imagination, offering mysteries that would take lifetimes to explore. The light speed barrier does not lock you away from these wonders. It simply sets the price of admission. That price is time itself. Trade your connection to one moment in history, and the universe will carry you across distances that would make the gods of ancient mythology weep with envy. Hold fast to your era, and the cosmos remains a beautiful prison, visible through telescopes, but forever beyond physical reach. The choice, when humanity is ready to make it, will reveal what we value most: range or connection, exploration or belonging. The stars are home. The universe waits, patient and indifferent, to see which we choose. Sleep well. Rest deeply. Let the strange truth of relativistic physics carry you into peaceful dreams. The stars are not impossibly distant. They are simply expensive. And the currency the universe demands is time. The light speed barrier stands. Absolute. Impassable. Built from mathematics itself. And yet, somehow, it is not a wall but a door. Not a prison, but an invitation. Not a limitation, but a revelation about the deep structure of reality. Close your eyes now. Let the equations fade. Let the numbers dissolve. Keep only the wonder. The universe is stranger than you imagined. More flexible. More generous. More willing to bend its rules than seems possible. It does not trap us. It simply requires that we understand the price of escape. And that price, measured in the currency of time itself, remains ours to pay or refuse as we choose. But before you drift completely into sleep, let's explore a few more layers of this mystery. Because the story of light speed is not just about physics. It is about what it means to move through a universe that has written its rules in mathematics. Deep beneath the border between Switzerland and France, in a tunnel 27 kilometers in circumference, lies one of humanity's most ambitious scientific instruments. The Large Hadron Collider, built over decades at a cost of billions of dollars, exists for one purpose: to smash particles together at the highest energies ever achieved on Earth. Inside this machine, protons race around the ring at 99.9999991% of light speed. At this velocity, the protons complete over 11,000 laps around the 27-kilometer ring every single second. They are moving so fast that time itself has nearly stopped for them. From the proton's perspective, the ring it races around has compressed from 27 kilometers to about 10 centimeters. For inches, the entire massive collider, with its superconducting magnets and vast experimental halls, has squeezed down to less than the width of your hand. Let that settle as you rest. Space itself has contracted, not metaphorically, not as an optical illusion. The distance these protons must travel has literally, physically shortened to a tiny fraction of what stationary observers measure. At this velocity, time dilation is extreme. For every second that passes in the laboratory, only about 0.00014 seconds pass for the proton. Put another way, for every 7,000 seconds the proton experiences, a full second passes in our world. The proton is living in extreme slow motion from our perspective. These protons have been accelerated through stages, each one adding energy. First, they are stripped from hydrogen atoms. Then they are accelerated through a linear accelerator. Then through a series of circular accelerators, each one larger than the last, each one adding more energy. By the time they enter the Large Hadron Collider's main ring, these protons are already moving at a significant fraction of light speed. The final acceleration, in the main ring, pushes them to that final 99.9999991%. The energy in each proton at this speed is approximately 7 teraelectron volts. This is a tiny amount of energy by everyday standards, roughly equivalent to the kinetic energy of a flying mosquito. But concentrated into a single subatomic particle, it represents energy density beyond anything found naturally on Earth. More importantly, these protons have gained relativistic mass. Each proton, at rest, has a mass of approximately 1.67 times 10 to the negative 27th kilograms. A number so small it defies everyday comprehension. But at 99.9999991% of light speed, each proton behaves as though it has about 7,000 times this rest mass. The proton has not physically grown larger. No additional quarks have been added. But the energy of its motion has become so enormous that it manifests as mass. Einstein's E equals mc squared in perfect action. Now here is the crucial point. To push these protons just slightly faster, to add one more 9 to that percentage, would require doubling the energy. To reach 99.9999991% would require doubling it again. Each additional 9 requires roughly doubling the energy of the entire machine. The Large Hadron Collider already consumes power equivalent to a small city. It requires superconducting magnets cooled to temperatures colder than outer space. It took decades to build and represents the combined effort of thousands of physicists and engineers from dozens of nations. And yet, despite all this power, all this sophistication, all this effort, the machine cannot push particles that final infinitesimal distance to light speed. The barrier holds. The universe says no. As your breathing slows, appreciate what this means. We have tested the light speed barrier with the most powerful machines ever built. We have pushed particles to velocities so extreme that their behavior defies everyday intuition. And every experiment confirms what Einstein predicted over a century ago. The barrier is real. It is absolute. And it is enforced by the structure of space-time itself. Now let's explore one of the strangest consequences of time dilation. A puzzle that troubled Einstein's critics for years, until the resolution revealed something profound about the nature of time. Imagine two twins, Alice and Bob. They are born on the same day, in the same hospital, identical in every way. When they turn 30, Alice decides to become an astronaut. She boards a spacecraft capable of traveling at 99% of light speed. Bob remains on Earth. He watches his sister's ship accelerate away, climbing to relativistic velocity, heading toward a star 50 light-years distant. From Bob's perspective on Earth, Alice's journey unfolds as follows. She accelerates to 99% of light speed. She coasts for most of the journey. As she approaches the distant star, she flips her ship and decelerates. The total journey time, from Bob's perspective, is approximately 50.5 years. During this time, Bob ages 50.5 years. He was 30 when Alice left. He is now nearly 81 years old. His hair has turned white. His children have grown and had children of their own. Half a century has passed. But for Alice, traveling at 99% of light speed, time has passed much more slowly. The time dilation factor at this velocity is approximately 7. For every 7 years that pass on Earth, only 1 year passes for Alice. Her journey to the distant star takes approximately 7.2 years of her own time. She ages 7.2 years during a journey that Bob measures as 50.5 years. She left Earth at 30. She arrives at the star at age 37. If she immediately turns around and returns to Earth at the same velocity, the same time dilation applies. Another 7.2 years of her own time. Another 50.5 years of Earth time. When Alice returns to Earth, Bob is approximately 131 years old. He has been dead for years, having lived a long, full life. But Alice is only 44 years old. She has aged 14 years during a journey that consumed an entire Earth lifetime. Let this strangeness wash over you as you drift. The twins, born on the same day, are no longer the same age. Time itself has flowed at different rates for them. This is not a trick or an illusion. This is a measured, verified, absolute property of the universe. Early critics of relativity argued that this scenario created a paradox. They said, from Alice's perspective, she was stationary while Earth moved away at 99% of light speed. So shouldn't Bob be the one who ages less? How can both twins claim the other aged less? The resolution lies in the asymmetry of the situation. Bob remained in a single reference frame the entire time. He never accelerated. He never felt any force pushing him. He simply sat on Earth, in its gentle gravitational field, watching his sister's ship depart and return. Alice, on the other hand, experienced acceleration. She felt force when her ship's engines fired to reach 99% of light speed. She felt force again when she decelerated at the distant star. She felt force a third time when she accelerated back toward Earth. And she felt force a fourth time when she decelerated upon arriving home. This acceleration breaks the symmetry. It marks Alice as the traveler and Bob as the one who stayed home. And it determines who ages less. The physics is clear. The one who accelerates ages less. Always. Without exception. This is not just theory. This effect has been measured with atomic clocks flown on airplanes. The flying clocks, experiencing the acceleration and velocity of flight, showed slightly less elapsed time than identical clocks that remained on the ground. The effect was tiny, measured in nanoseconds, because airplane velocities are tiny compared to light speed. But it was real, measurable, and exactly what relativity predicted. GPS satellites must account for time dilation. The satellites orbit at high velocity, and their clocks run slightly slower than clocks on Earth because of this velocity. If GPS did not correct for time dilation, positioning errors would accumulate at a rate of about 10 kilometers per day. Your navigation would be useless within hours. Every time you use GPS, you are relying on corrections for time dilation. Every time your phone tells you where you are, it is using Einstein's equations to account for the fact that time passes at different rates for objects moving at different velocities. The universe does not make exceptions. The rules apply everywhere, always, to everything. Time dilation is not something that happens in exotic physics experiments. It is woven into the fabric of everyday technology. As you rest now, let that sink in. The universe you inhabit is stranger than everyday experience suggests. Time is not a universal river flowing at the same rate everywhere. It is flexible, malleable, dependent on motion and gravity. And this flexibility is not a flaw or a glitch. It is a fundamental feature of reality. Now let's explore what this means for the practical dream of visiting other stars, and why time dilation is both a gift and a curse. We have seen that time dilation allows travelers to reach distant destinations in subjective time frames much shorter than Earth observers would measure. This seems to solve the problem of interstellar travel. Simply accelerate to high velocity, let time dilation compress the journey, and arrive having aged only modestly. But this solution comes with a cost that cannot be avoided. Every journey becomes a one-way ticket through time. Consider a journey to a star 100 light-years from Earth. At 99.9% of light speed, the journey would take approximately 100 years from Earth's perspective. But from the traveler's perspective, time dilation compresses this to about 4.5 years. You could leave Earth at age 30 and arrive at the distant star at age 34.5, having experienced less than 5 years of travel. From your perspective, the journey would feel manageable, not much longer than a college education. You would arrive young, vigorous, capable of exploring and working. But Earth would have aged 100 years. Everyone you knew would be dead. Your children, if you had them, would be elderly or deceased. Your grandchildren would be old. Your great-grandchildren would be in their prime. The civilization you left would be a century older. Language would have evolved. Technology would have advanced. Culture would have transformed. Politics, values, social structures, everything familiar would have changed in ways you cannot predict. You could return to Earth, making the same journey in reverse. Another 4.5 years of your time. Another 100 years of Earth time. You would arrive home at age 39, having been gone for 9 years of your own experience. But Earth would have aged 200 years since your departure. You would return to a world as different from the one you left as the early 1800s are from today. The Industrial Revolution had just begun in 1820. Photography had not been invented. Railroads were experimental. Slavery was legal in most of the world. This is the temporal gulf you would cross. You cannot visit the stars and return to the same era. Every journey is a journey forward through time, from which no return to your departure point is possible. Let this weight settle as you drift toward sleep. The universe offers cosmic exploration at the price of temporal exile. You can touch the stars, but you abandon your era. You can cross light years, but you sacrifice connection to everyone you know. Some travelers might accept this trade willingly. The wonder of seeing new worlds, of standing beneath alien skies, of exploring star systems no human has ever witnessed, might be worth any personal cost. The opportunity to be humanity's ambassador to the cosmos might justify leaving everything behind. But others might find this price too high. Connection to family, to community, to a specific moment in human history might matter more than distance traveled or wonders seen. The choice to remain might be not a failure of courage, but a different kind of courage entirely. The universe does not judge these choices. It simply enforces its rules. Time dilation is real. The speed of light is absolute. The cost of cosmic travel is measured in years of Earth history that you will never experience, decades or centuries that pass while you age only slightly. Now, as we drift deeper toward rest, let's consider why we might not see evidence of other civilizations traveling at these extreme velocities, and what it suggests about the universe we inhabit. If relativistic travel is possible, if time dilation allows journeys across cosmic distances within biological lifetimes, why do we see no evidence of other civilizations doing this? Why is the galaxy not full of starships racing between worlds at 99% of light speed? The energy requirements provide one answer. We have seen that accelerating even a small spacecraft to relativistic velocities requires energy comparable to stellar output. To reach 99% of light speed requires seconds or minutes of a sun's complete power. To reach 99.9% requires significantly more. A civilization capable of harnessing such energies would be visible across interstellar distances. The waste heat from engines powerful enough to produce these accelerations would radiate across light years. The deceleration burns upon arrival would be like localized stars appearing and disappearing. We see nothing. The galaxy appears quiet. The enormous energy signatures that would accompany routine relativistic travel are absent from our observations. Perhaps life is rare. Perhaps intelligent civilizations destroy themselves before developing such capabilities. Perhaps the technological challenges are even greater than we imagine, and no one has yet solved them. Or perhaps the energy barrier is simply too high. Perhaps the universe has designed a cosmos where each star system remains fundamentally isolated, where life evolves and flourishes in lonely archipelagos, separated by gulfs too expensive to cross regularly. The silence suggests that if relativistic travel is possible, it is either extremely rare or extremely expensive, even for civilizations far more advanced than ours. The galaxy is not full of travelers because the universe charges too much for the ticket. Another possibility is that civilizations capable of relativistic travel choose not to use it for the reasons we have explored. The temporal exile, the loss of connection to their own era, the one-way nature of the journey through time, might be prices that most choose not to pay. A civilization might develop the capability to reach 99.9% of light speed and then collectively decide that the cost is too high. That maintaining connection across generations, preserving cultural continuity, staying rooted in their own temporal moment, matters more than spreading across the stars. This would explain the silence we observe, not because relativistic travel is impossible, but because those who can do it choose not to. Because the universe's price for cosmic exploration is higher than most are willing to pay. As your eyes grow heavy, rest in this uncertainty. We do not know if we are alone. We do not know if others have solved the problems we face. We do not know if the silence is temporary or permanent, a matter of timing or a fundamental feature of how the universe operates. What we do know is that the universe has rules. Light speed is absolute. Time dilation is real. Energy requirements are enormous. And these rules apply to everyone, everywhere, always. Now, as we approach the edge of sleep, let's gather all these threads and understand what they reveal about the cosmos we inhabit. We began tonight with a barrier that seems absolute. The speed of light, 186,282 miles per second, stands as an impassable limit. No amount of engineering, no cleverness, no determination can exceed it. The universe enforces this limit through the fundamental structure of spacetime itself. As objects with mass approach light speed, their effective mass increases toward infinity. The energy required to continue accelerating climbs exponentially. The final approach to light speed demands infinite energy, which does not exist. Therefore, light speed cannot be reached by anything with mass. This is not an engineering problem awaiting a solution. This is not a challenge to overcome with better technology. This is mathematics. This is the way the universe works. And mathematics does not compromise. Yet within this seemingly absolute limitation lies a profound loophole. Time itself bends to preserve the constancy of light speed. For fast-moving observers, time passes more slowly. Durations that Earth measures in years compress to months, weeks, days, or even hours for travelers at extreme relativistic velocities. This time dilation transforms the landscape of cosmic exploration. Destinations that light requires decades to reach become accessible in subjective years. Stars that seem forever distant become reachable within a human lifetime, measured in the traveler's own time. The universe has not imprisoned us. It has simply set its price. The cost of reaching the stars is not exceeding light speed, which is impossible. The cost is accepting that your journey will carry you forward through time, that you will age slowly while the Earth ages rapidly, that you can visit distant worlds but cannot return to the era you departed. This is the universe's bargain. It offers cosmic exploration to anyone willing to pay the temporal price. It forbids exceeding light speed absolutely, but it bends time and space to make light speed unnecessary for those who understand its rules. The mathematics works. The physics permits it. Journeys to nearby stars become manageable. Journeys to the galactic center become possible. Journeys to other galaxies become conceivable for those willing to invest enough velocity and accept the temporal consequences. But the energy requirements remain staggering. Accelerating even small spacecraft to velocities where time dilation provides substantial benefit requires energy measured in stellar output. The engineering challenges span generations of development. The commitment required exceeds what human civilization has yet demonstrated. And even if we solve these challenges, even if we build engines capable of reaching 99.9% of light speed or higher, the fundamental choice remains. Do we value range or connection? Exploration or belonging? The stars or our own moment in history? The universe does not make this choice for us. It simply enforces its rules and waits to see what we decide. The barrier stands, absolute and impassable. But the barrier is not a wall. It is a door with a very specific price of admission. As you rest now, let all the equations and numbers fade away. Keep only the essential truth. The universe operates according to rules written in mathematics. These rules are not arbitrary. They are not designed to frustrate us. They simply are. Light speed is absolute because space-time has a structure, and that structure enforces limits. Time dilation is real because space and time are not separate things, but aspects of a unified space-time that bends and flexes to preserve certain invariant properties. The universe we inhabit is stranger and more wonderful than everyday experience suggests. Time is not a universal clock. Space is not a fixed stage. Both are dynamic, flexible, responsive to motion and energy. Both conspire to create a cosmos where laws remain consistent even as observations differ. And within this strange, flexible, mathematical universe, the speed of light stands as an absolute. Not because nature is cruel or limiting, but because this limit is woven into the very fabric of how reality is constructed. You cannot exceed light speed, but you can use the universe's own flexibility, its willingness to bend time and compress space, to accomplish journeys that would seem impossible under Newtonian physics. The door is open. The path is clear. The universe has shown us how to reach the stars without violating its fundamental laws. Whether we walk through that door, whether we pay the price it demands, remains our choice to make. For now, rest. Let your breathing slow. Let the strangeness of relativity settle into background awareness. The universe will still be here tomorrow, still enforcing its rules, still offering its strange bargain to anyone willing to understand the terms. The light speed barrier stands. Absolute, impassable, enforced by mathematics itself. And yet, somehow, it is not the end of the story but the beginning. Not a limitation, but an invitation to understand the universe more deeply. Sleep well. Dream of photons racing through space-time, experiencing no time at all. Dream of spacecraft approaching light speed, time slowing, space contracting, the stars coming near. Dream of a universe that says yes in unexpected ways, even as it says no to the obvious path. The barrier is real. The barrier is absolute. And the barrier, paradoxically, is how the universe shows us the way forward. By denying us one path, it illuminates another. By forbidding one kind of journey, it makes possible a different kind entirely. Close your eyes now. Let it all go. The equations, the velocities, the impossible energies. Keep only the wonder. The universe is built on principles so profound that a 26-year-old patent clerk could glimpse them with nothing but thought and mathematics. Those principles still hold, still govern, still describe with perfect precision how matter, energy, space, and time relate to one another. And nestled within those principles is the answer to how far we can go and what it costs to get there. The cosmos awaits, patient and vast. The light speed barrier stands, impassable and absolute. And between these two truths lies everything that matters about our potential future among the stars. Good night. But wait. Before you slip completely into sleep, there is one more layer to this story. One more truth about the light speed barrier that changes everything we think we know about our place in the cosmos. We have explored the barrier from the perspective of travelers trying to move fast. But what does this barrier mean for the universe itself? What does it tell us about the fabric of reality and our role within it? The speed of light is not just a speed limit for spaceships. It is the speed at which causality itself propagates through the universe. It is the maximum rate at which cause can influence effect. When you flip a light switch, the electromagnetic signal travels down the wire at light speed. When the sun undergoes a fusion reaction, the light from that reaction takes 8 minutes to reach Earth, traveling at light speed. Nothing can influence anything else faster than light speed. This is not a limitation of communication technology. This is a fundamental property of how the universe is structured. Cause and effect are limited by the speed of light. This creates something called the light cone. For any event in space-time, there is a region of past events that could have influenced it, and a region of future events that it could influence. These regions are defined by light speed. Nothing outside your light cone can affect you. Nothing you do can affect anything outside your light cone. You exist within a sphere of influence that expands at light speed. Everything within that sphere can potentially interact with you. Everything outside that sphere is, in a very real sense, not part of your universe. It exists, but it cannot touch you, cannot influence you, cannot know about you until enough time passes for light to bridge the gap. Let this settle as you rest. The light speed barrier does not just limit how fast you can travel. It defines the structure of causality itself. It determines which events can influence which other events. It shapes the very meaning of past, present, and future. In a universe with infinite speed, everything would be connected to everything else simultaneously. There would be no meaningful notion of distance, no separation between events, no structure to space-time at all. Cause and effect would be simultaneous and universal. But in our universe, with its finite light speed, there is structure. There is separation. There are regions of space-time that cannot yet know about each other. And this separation, this limit on how fast influence can propagate, is what gives the universe its shape and meaning. The light speed barrier is not a bug in the cosmic code. It is a fundamental feature that makes the universe comprehensible, structured, governed by laws rather than chaos. Now consider what this means for the expansion of the universe. We have said that space itself is expanding, carrying distant galaxies away from us faster than light. How is this possible if nothing can exceed light speed? The answer lies in the difference between moving through space and the expansion of space itself. Objects moving through space are limited by light speed, but space itself can expand at any rate. There is no limit on how fast space can stretch. This means that distant galaxies, carried along by expanding space, can recede from us faster than light. Not because they are moving through space at superluminal velocities, but because the space between us and them is growing. These galaxies have not violated the light speed barrier. They have not accelerated to forbidden velocities. They are simply being carried along by the expansion of the medium in which they exist, like boats drifting apart on a swelling ocean. And here is the profound consequence. There are galaxies so distant that space is expanding between us and them faster than light can cross the gap. Light leaving those galaxies today, heading toward Earth, will never reach us. The space it must cross is expanding faster than the light can travel through it. These galaxies are permanently beyond reach. Not just practically beyond reach, not just too far to visit with current technology, but fundamentally, absolutely beyond reach. Even if you could travel at 99.9999999% of light speed, even if you could approach light speed as closely as physics permits, you could never reach these galaxies. The expansion of space has created a horizon beyond which we are forever isolated. The universe contains regions we can never visit, never influence, never communicate with, no matter how long we wait or how advanced we become. Let this cosmic loneliness wash over you as you drift. The universe is not just vast in space. It is structured in such a way that most of it is permanently inaccessible. The light speed barrier, combined with cosmic expansion, has created islands of causality, regions that can interact within themselves but never reach beyond their boundaries. We inhabit one such island. The observable universe, that sphere approximately 93 billion light-years across, represents not just what we can currently see, but increasingly what we can ever interact with. As expansion accelerates, driven by dark energy, this sphere of accessibility shrinks rather than grows. Galaxies we can see today will, in the distant future, cross beyond the horizon and disappear forever. Future astronomers, billions of years from now, will observe a much smaller universe than we do. They may never discover that other galaxies existed. The evidence will have been carried away by expansion beyond the reach of light itself. This is the ultimate consequence of the light speed barrier. It does not just limit how fast we can travel. It defines the boundaries of possible interaction. It creates a universe of isolated regions, each unable to reach beyond its own horizon, each evolving in isolation from the others. And yet, within our accessible region, within our island of causality, the universe remains vast beyond comprehension. 2 trillion galaxies, hundreds of billions of stars in each, countless worlds, countless possibilities, countless opportunities for exploration and discovery. The light speed barrier has not imprisoned us in a small space. It has defined for us a region of responsibility. This is the volume of the universe we can potentially influence. These are the stars we might reach. These are the galaxies within our domain. Everything beyond our horizon exists, but exists in a way that is forever separate from our story. We are not responsible for those distant regions because we can never reach them. We are responsible for our own cosmic neighborhood, the volume of space within our light cone, the region where our choices and actions can have consequences. As your breathing slows and deepens, consider what this means for the human story. We are not the center of the universe. We occupy no privileged position. We are one species on one planet orbiting one star in one galaxy among trillions. But we exist within a region of space-time that is ours to explore, understand, and potentially spread across. The light speed barrier defines the boundaries of that region, not to limit us, but to give us a comprehensible domain, a cosmic neighborhood within which we can make a difference. The universe is not testing us with the light speed barrier. It is not punishing us or restraining us. It is simply showing us the structure of reality. Space-time has properties. Those properties have consequences. And one of those consequences is that influence propagates at finite speed. Within this structure, everything we have explored tonight becomes clear. Time dilation is not a trick, but a necessary consequence of preserving the constancy of light speed. Relativistic mass increase is not a punishment, but a manifestation of energy mass equivalence. Length contraction is not an illusion, but a real property of how space responds to motion. All of these strange effects follow from one simple principle. The speed of light is the same for all observers, regardless of their motion. Everything else, all the weirdness of relativity, all the time dilation and space contraction and mass increase, all of it exists to preserve this one invariant property. The universe has chosen consistency over intuition. It has built a cosmos where fundamental laws remain the same for everyone, everywhere, even if this requires space and time to behave in ways that contradict our everyday experience. This is the bargain reality has made. Absolute physical laws in exchange for flexible space-time. Universal consistency at the cost of abandoning absolute simultaneity. A cosmos governed by comprehensible mathematics rather than arbitrary caprice. And we, conscious beings emerging from matter and energy, find ourselves in a position to understand these rules, to glimpse the deep structure underlying appearances, to see that the universe is not random or chaotic, but ordered according to principles we can discover and describe. The light speed barrier is one of those principles, perhaps the most fundamental. The cosmic speed limit that defines causality, structures space-time, and determines what is possible and what is forbidden. You cannot exceed it, but you can work within it. You can use time dilation to compress journeys. You can exploit the flexibility of space-time to reach distant stars. You can accept the universe's terms and still accomplish wonders. This is the human condition in a relativistic universe. We are bound by rules we did not make, limited by barriers we cannot break, subject to laws that care nothing for our desires or dreams. And yet, within these constraints, almost anything becomes possible for those patient and clever enough to work with the grain of reality rather than against it. The stars are not impossible to reach. They are simply expensive, with the currency being time itself. The galaxies are not forever beyond our grasp. They are just very far away, requiring velocities and energies we have not yet learned to produce. The light speed barrier stands, absolute and impassable, but it is not a wall enclosing a prison. It is a boundary defining a domain. Our domain. the region of space-time within which we exist and can potentially flourish. Everything within that domain, every star system we can see, every galaxy within our horizon, every cubic light year of accessible space, all of it remains open to us. Difficult to reach, yes. Requiring technology we do not yet possess, certainly. Demanding patience and resources and commitment across generations, absolutely. But not forbidden, not impossible, not barred by the fundamental laws of physics. Simply waiting for us to understand the rules well enough to play by them successfully. As you finally release into sleep, let this truth carry you gently down. The universe is vast, strange, and wonderful. It operates according to rules that seem designed to frustrate our intuitions while rewarding our understanding. It offers no easy paths, but it leaves every meaningful path open to those willing to learn. The light-speed barrier is not our enemy. It is the universe explaining its nature to us, showing us that consistency matters more than convenience, that some limits are absolute not because nature is cruel, but because reality has a structure that makes existence meaningful and comprehensible. We live in a relativistic universe. Time is flexible. Space is malleable. Mass and energy are equivalent. Cause and effect propagate at finite speed, and nothing with mass can ever reach light speed. These are not limitations imposed on us from outside. They are descriptions of how the universe actually works. The rules were here long before we evolved to discover them. They will remain long after we are gone. They are not for us or against us. They simply are. And we, miraculous assemblies of matter that have become conscious enough to understand the rules governing our own existence, stand at the threshold of a cosmic future whose boundaries are defined not by physics, but by our own choices. The barrier stands. The door is open. The stars await. And the universe watches, patient and vast, to see what we will do with the strange gift of understanding it has given us. Sleep well, dreamer. Rest deeply. Tomorrow, the universe will still be here, still vast, still mysterious, still governed by that beautiful, impassable limit that makes everything meaningful. The speed of light, the cosmic constant, the absolute barrier that, paradoxically, shows us the way forward. Good night, traveler. May your dreams carry you across light years, freed from time's weight, touching stars that actual journeys would take lifetimes to reach. In dreams, at least, the barrier does not hold. And when you wake, the universe will welcome you back to the slower, stranger, more wonderful reality we actually inhabit. A reality where light speed is absolute, time is relative, and the cosmos is waiting to be understood by minds capable of grasping its deep mathematical beauty. Close your eyes. Let it all go. The universe will keep its secrets and reveal them in equal measure, according to its own mysterious schedule. And you, for now, need simply rest. The barrier holds. The story continues. And somewhere in the space between sleep and waking, between now and tomorrow, between Earth and the distant stars, the truth remains. We cannot travel at light speed, but we do not need to. The universe has shown us another way, and that way, though different from what we imagined, remains open, forever open, waiting, patient as only the cosmos can be. Good night.